we're on. So lesson 3 is analyzing the graph y equals a times, in brackets, x minus h squared plus k. So this is a whole new formula today, but it's still a quadratic formula. So last day, let's just review what we learned last day. Last day we learned that a quadratic function is a function of degree 2, which can be written in the form ax squared plus bx plus c. Okay, so where a, remember, was positive or negative. If it was positive, it opened up. Negative, it opened down. So that's what we covered last Thursday. Another name for a quadratic function is a parabola. Just another name. If it has a maximum point, so if it has a maximum, that we would say it opens down. A maximum opens down, and if it has a minimum, then it would open up, right? It's like a smiley face. Sad, happy. Yeah. The vertex, the actual max or min point, is what we call the vertex. So that's the actual point. So it's going to be a point x comma y. And then, and that's the maximum or minimum point. And last, the maximum or minimum value is going to be the y coordinate. So the y coordinate of the vertex, so if this is x comma y, the y would be the actual max or min value. What did we use the x for? What do we call that? X, what would we use that for? Remember the dotted line in the middle? Cuts it in half. What do we call that line? Symmetry, the axis of symmetry. Okay, so the axis of symmetry is wherever x is. So x equals 2. If this value was 2, x equals 2 would be the axis of symmetry, where it cuts it in half. Okay, so we're going to do a little investigation here. So what I'd like you to do is, with your calculator, we're going to graph both functions. So let's graph one at a time. So you need a graphing calculator. So the first one, go to y equals. If you have anything there, we're going to clear it. Okay, so f of x is another way to write what? Y. So it's still y equals. We'll type in x squared minus 6x plus 11. Let's graph that. Oh, my windows are weird. How do we put them back to normal? Zoom 6. And enter. There it is. Okay. Now we want to graph the other one as well. Okay, we want to graph the other one as well. So what we'll do is we'll type it in as well. So it looks like bracket x minus 3 bracket squared plus 2. But let's go over all the way to the left and make it bold. So by pushing it enter once, now we'll have a bold line. So I went all the way to the left and push enter once, and now it's bold. So if I go back arrow, you'll notice one. So let's push graph. And Jesse says it's the same thing. So push graph and see if you agree. Graph. These are the same line. Yeah, it just traced the other one. So they look different, but actually they are the same line. They are the same. So it says expand g of x. So what does it mean to expand? If we have g of x, what do they mean by that? What part are we expanding of g of x? Well, g of x is just another way to write y. So really it's like y equals x minus 3 squared plus 2. Which part can we expand it? The squared. X minus 3 squared. How can you write x minus 3 squared? How else would we write that? Double it. Or double it is times 2. X minus 3 times multiply by itself. That's what you meant. Great. Why? Because we want to show that they actually are the same. Okay, so what do you do when you have a binomial times a binomial? What's it called? FOIL. So FOIL, so F means the two first together. So x times x is x squared. Then we want the outside, so x times negative 3. That's the O. Negative 3 and x, negative 3x. Now the insides, or negative 3 times the x. Same thing, negative 3x. And the last, negative 3 times negative 3. Yeah, be careful of signs. 2 negatives, positive 9. And then we still have what? Plus 2. So last step is we want to collect like terms. So x squared. What's minus 3 plus minus 3? Or negative 3 plus negative 3? Negative 6x. And 9 plus 2? 11. Is that the same as f of x? Yeah, which is equal to f of x. So they are the same. You do have to show that algebraically. Stacy, would it help you if you were here? You sure? Are you sitting here? You can, if it will help you. You can make that decision yourself. Can you say why? Yeah, or I don't know why I wrote squared here. There's no squared. I don't know why that was there. Okay. All right, same idea. I want you to graph both. Tell me what you see. Are they going to be the same again or not? So try it out. Graph them both. Maybe, maybe not. Okay, I'll try it. Prove it to me. X minus 77. Got an error. So check that you make sure you're putting a minus 2, your minus there instead of a negative. Right? Be careful for your negatives and your minuses. A negative should only be put in if there's nothing else in front of it. So when you graph, first, second. I did. There it is. Okay, so they're the same. So why don't you try expanding the second one this time? See if you can do that. But prove it to me algebraically. So how do we prove it algebraically? We have to actually show. Yeah, try by yourself. The only thing that I'd say be careful of, let me just get you started. X plus 5 squared, how else would you write that? X plus 5 times x plus 5. So when you FOIL, you still need to keep brackets because there's that negative 3 in front. So FOIL it out, and then we'll bring that negative 3. So practice FOILing this. I want you to practice that step, Jesse. So FOILing it out. Practice that x plus 5 times x plus 5. So first, outside, inside, last. Okay, so x times x, you would have had x squared, x times the 5, plus 5x, and then 5 times x, plus 5x. What do you notice? They're always going to be the same in the middle. And then plus 5 times plus 5 is plus 25. So from here, let's collect like terms inside. So what can you collect inside there? The 5x and the 5x. X, which equals 10x. And now we can bring in the 3, the negative 3. So we have to use distributive law to each one of these. What's negative 3 times x squared? Negative 3x squared minus 30x and then minus 75, but we still have a minus 2. So that becomes minus 77. Yeah, and that's okay if you do that. Go straight to that. Okay, and now we can prove, yeah, they are the same function. That is the other y. Hey, they're the same. Same. That is a good thing. So what does that mean for us? Well, we have two different equations, two ways to write it. And does that tell us anything about the graph? We're going to take a look. So, well, these type of problems are, like, even when they made, like, Angry Birds, right, the parabolas. Anytime you're doing any parabolic type shape, right, we can use this type to function. Throwing a football. Yeah, so it applies to physics a lot, actually. Okay, so general form. We've learned general form before. General form, I don't know if you want to highlight that or underline it, is ax, well, it's different than, it's y equals ax squared plus bx plus c. Don't think of general form from linear equations. Think totally different. This is, no, well, we learned another general form of a line. This is okay, but this is not lines, this is parabolas. So we looked at this day 1, lesson 1 and lesson 2 was general form. Ax squared plus bx plus c. Okay? And yeah, you could either make it y equals or f of x equals. Standard form is like that equation we just started looking for. Okay, that's called standard form. So you need to know the difference between general and standard. Now notice there's different variables. What variables are different? In h and k. So sometimes standard form is called vertex form. I wonder why that might be. Okay, well let's look at this. So what we're going to do is we're going to grab our graphing calculators, and we're going to graph y equals x squared on our graphing calculator. So y equals, clear both of those, x squared. So everything is actually compared to x squared. So what's our a value? A value is the number in front of x squared. What is it if you can't see it? No, 1. The coefficient would be 1. So here a is 1. Now it says h and k. Just looking at it, is there an h or is there a k? No, so they're both 0. And interesting enough, when we look at our graph, what's the vertex? 0 and 0. Do we even need to calculate the minimum value, or can you figure it out just by looking at it? Yeah, 0, 0. Okay, let's look at this guy. What's our a value? So comparing it to this form, it's the number in front of the brackets. If you don't see it, it's a 1. Move that 1 over. So a is 1. Now, comparing it to this formula, what's the h value? Careful, it has a minus sign in the formula. So it actually would just be 2. And k is, well, you're adding nothing. So 0. So let's graph this guy. Erase that plus 0. Let's graph it. Oops. That's not what I want. Here it is. Oh, okay. Or something. Okay, so y equals, I want you to bracket x minus 2 squared and graph. Okay, now we need to find, is it our vertex? Our vertex, is it going to be a max or a min? Look at it. Smiley face is minimum, right? There's going to be a lowest point. It keeps going up, so there's no maximum. It's going to keep going up. But it does have a lowest value, and that would be the minimum. Okay? So, minimum, how do we find minimum on our calculator? How do we find it? Second, calc or trace, and then number 3. Now, here's where it's really, what do we have to do? It says left bound. Are we on the left side of it? Yes. Yep, push enter. The trace button. And we scroll over to the right bound. So we want to go on the right side of it. Doesn't matter where? No. And then it says make a guess. So I think it's approximately right there. Enter. And then it actually calculates it. So what would it actually be? 2 and 3. This is times 10 to the negative 12. That's actually really, really... Did anyone else get something different? Yeah, negative... This is actually really close to 0. Because if we move the decimal point, keep going, right? It's only approximating it. It's not... Our calculator can't do it perfectly. So it's actually 2, and that's 0. Well, if it can calculate it, it will. So 2, 0 is our minimum. Well, it can mostly do it. Yeah, so 2.000, that's 2, and that's still 0. When you have times 10 to the negative 12, your 12 decimal place, you have to move it 12 to the left. Okay, next guy. What's your A value? 1. Okay, here comparing it to the formula, what would be your H?
4.
Ooh, it's x minus h. It'd have to be a negative 4. Because minusing a negative makes a positive. And k is 0. Well, the formula has a minus, so inside, it's always opposite sign. It'd be positive, and if it's positive, it's negative. You're guessing it's going to be negative 4, 0. Let's take really quick. So x plus 4, graph, second, trace. Now we still have a minimum. So left of it, go to the left side. Enter, go to the right side. Enter, and enter. Hopefully it's a little bit better this time. So that'd be negative 4, and is that really close to 0? Yeah. Okay, so are you seeing a pattern here? Okay, are we seeing a pattern? Well, in this case they are. Let's look at a different example. What's wrong?
Like for y.
But it's really close. It's just because of where your left bound and right bound is. That's why. That's all it is. Yeah. Okay, let's try one more. A value is 1. What would your H be? Plus 2, because the formula x minus h, so positive 2. Now it's plus k, so what's the k value here? It's the same sign for k, so negative 3. So if we graph this, again, x minus 2 squared minus 3. Let's graph it. Okay, so minimum or maximum? Okay, so minimum, second trace. So we need number. Okay, 3. You should be in your calculator. You need to be doing this too. So left bound, enter, go to the right. Enter, then make a guess. Oh, come on.
Do all our questions get pulled up videos here?
If they can hear it. Exactly. Okay, so left side, right side. Jesse, in your calculator. Enter. So, trace, minimum. How come this is not working? Enter. I was using Intercept. And enter. There we go. So, negative, what would that be? 1.9999. 2 and negative 3. Oh, it's the same as my h and k. So what conclusion can we come to? Our vertex is h, comma, k. That's a nice thing about this form. So let's keep going without our calculator. What would be my h value here? Negative 4. Well, and positive 5. No? Because of the minus sign, the h is always opposite sign. Okay, I was wrong. 1. Your A is 1. Thank you. So negative 4, comma 5. Okay, next one. What's our A value? 6. Yeah. Positive 2 for H, negative 3, so vertex is 2, negative 3. Next guy, what's our A value? Negative 1 would be the number in front. Negative 4 is H, and K is positive 5, negative 4, and 5. Good. Okay, what does the A value tell you? What does the A value tell you? Do you remember from last day? If it's positive, it opens. Yeah, it's opening up, and if it's A is greater than 0, and A is negative, it opens down. That's what A does. Okay, and it also stretches it. Yeah, negative A is sad. There you go. Okay, so in the table below, we're going to skip this. Actually, let's do 1 together. Let's do 1. Okay, so give me an A value. Let's do 1. 2 x minus, or we want plus, or do you want to do minus? Minus 4 squared
25.
plus 25. Okay, so what would the A value be then? 2. H would be positive 4, positive 25 for K, and vertex then would be H comma K, 4, 25. And so the axis of symmetry, well, if our vertex is at 4 and 25, okay, remember the axis of symmetry is whatever your x value is. What's the x value? 4. So it'd be x equals 4. And which way is this guy opening if it's a positive 2a? Up. Yeah. Okay. So moving on to the next page. What we're going to do is we're going to actually review quadrants. So if you have a graph, does everyone know where quadrant 1 is? Yeah, quadrant. This is quadrant 1. Okay. Quadrant 2 is actually over here. Yeah, quadrant 3. There you go. Quadrant 4. Okay. So it says make an equation. It's opening up. So what does it tell you if it's opening up? What's positive? A is positive. So we need a positive A value. And we're going to have a vertex in quadrant 1. So give me a point that would be in this quadrant, in quadrant 1. X is, so a point. So X is 4, Y would be, give me a point, 6, 4, and 6. So notice how in quadrant 1, both X and Y are positive, right? Here's your X and Y. So this is positive, positive, negative, negative. Yeah. So give me a positive A value. Doesn't matter which one. 30? Okay. Positive 30? Let's do 2. Okay. 2. Okay. So so we're saying A is 2, and our vertex is going to be 4 and 6. So we're going to make the equation. Remember the equation in standard form is A times x minus h squared plus k. So what do we get? Y equals, what was our A? 2 times x minus 4, because the minus in the formula, squared plus 6. So let's double check if we actually made the equation right. So on your graphing calculators, I want you to graph that. See if it's in quadrant 1 and it's opening up. Okay. So 2 x minus 4 squared plus 6. Okay? Should be in quadrant 1, it should be opening up. So graph. Quadrant 1, yeah, that's quadrant 1, and is it opening up? Yeah, so we made it, that's correct. Okay, so next one says make an equation so that the vertex is in quadrant 4 opening down. Okay, so if a quadrant, so what's negative, x or y? Y is negative, X is positive. So give me a point, any point in this quadrant. So 4 and negative 6? Sure. Because X is positive, Y is negative in that quadrant. And if it's opening down, what does that mean? Maximum value, correct? And which variable does that affect in our equation up above? The A value. A has to be negative. So give me an A value that's negative. Negative 16, negative 4, it doesn't matter. Okay, doesn't matter. And we said we have to use 4 and negative 6 to be in quadrant 4. So let's make the equation. Give it a shot. Put it into that form. Practice plugging it in. Y equals negative 4 was our A value. I guess we should have used another number so it wasn't confused with the other ones. Now, is it still X minus 4? Is it? Or remember, this is H and this is K. H comma K. And the formula has a minus. So we have minus positive 4. So minus 4 squared. Plus K, what's our K value? Negative 6, so minus 6. And don't forget the square. Okay? Let's try another one. Vertex on the x-axis. Where's the x-axis? The x-axis is here. So we need a point on the x-axis. Doesn't matter what 0. What y is going to be 0 on the x-axis. So say we pick a point right here. What would x might be over there? Sure, negative 5 comma, what's y always on the x-axis? 0. So we know our vertex would be negative 5. Let's use negative 5 and 0. And it's opening up. So give me an A value that would work for opening up. 33, doesn't matter. Okay, so now I want you to try and plug that into the formula. And with that, plug it into that formula. That's on at the bottom. Right, this guy. Y equals. Remember, the vertex is H comma K. So our A is 30. X minus a negative 5 plus 5 squared plus, okay, what's our K? 0. Do you have to write plus 0? You don't have to. If you did, that's okay. There you go. Okay, so let's move on. Okay, so this guy, looking at equation, you should be able to look at it and figure out the vertex. Yeah, it's minimum value, all that stuff. So state the coordinates of the vertex. So what was it? Remember, we're comparing it to this equation. Y equals A times X minus H squared plus K. That is on your formula sheet, that general form. Where's our vertex of that formula? Where's the vertex at? H comma K. Okay, so what would my H be here? Negative 6. What would the K be? Negative 9. Remember, the only sign that switches is the X value because of the minus sign. It's the only one that switches. Okay, so what would be the vertex then? What's our H? Negative 6 comma my K is negative 9. That would be my vertex. Okay, the axis of symmetry. Which one of these would give you your axis of symmetry? Negative 6. How would you write that? It's an equation always. The equation of the axis of symmetry. So far, this graph, is it opening up or down? Up. It's a positive A value. And we know at negative 6, negative 9, is our vertex. It's opening up. So what's the axis of symmetry? X equals -6. It's always, a vertical line is always x equals. So x equals -6. So we just get it from the x coordinate. What's the minimum value? Which one of those will give you the minimum? Where's our minimum at? Looking at the graph. -9. The y value gives you your minimum. The x gives you your axis of symmetry. Okay, domain of the function. Domain, remember Dr. XY. So domain is x. So x is how far, which direction?
Right.
Left and right. Will it keep going to the left? Will it keep going to the right? Yeah, so how do you write that? X is an element of the reals. Range. Well, does the graph go forever up and down? No. It has a minimum, so it starts at -9. How would you write that? Y is greater than or equal to -9. Yeah. Okay, and last, it says determine the y-intercept. So we kind of rushed through that part, so we'll go through it right now. The y-intercept is always your constant if it's in general form. This is not general form, so you'd have to figure it out. The y-intercept, what value, the y-intercept, when you cross the y-axis, which one's 0, x or y? X. X is 0 at the y-intercept. So whenever we're looking for the y-intercept, we set x to 0. So with our equation, we're going to set x to 0 and solve. What's 0 plus 6? 6. What is 6 squared? 36 times 2? 72 plus 9? 81. My x all the way. Oh, was there a -9? It's not a +9. Sorry, guys. It's a -9 here. -9. 72 minus 9, which is actually 63. So it's way up there. Right, way, way up there. All right, number of x-intercepts. So in each case, sketch the graph of a quadratic function with the given number of x-intercepts. So 2 x-intercepts. Write a possible equation. So what does it mean? What's an x-intercept? What's an x-intercept? When it goes through the x-axis. We want twice it goes through the x-axis. Okay? So if we want 2 x-intercepts, let's say it's going to open up. We just need a vertex somewhere below. Anywhere below would work. So give me a vertex below. Let's say over here. -4, -6. Sure. And if it opens up. So give me an a value that would open up. Sure. So what would that equation look like if we're writing it in this form? So y equals 3 times x. What's the h? +4 squared minus 6. Should we verify that that actually is happening? Sure. Just watch. You don't have to type it in. You can just watch. So here we have 3 times x +4 squared minus 6. Did that have 2 x-intercepts? Yeah. Okay, next one. 1 x-intercept. So what does that mean if we have 1 x-intercept and it's quadratic? No, it still has to be quadratic. It still has to be a U shape. 1 x-intercept. It's on, the vertex has to be on, oh, there you go. That your vertex would actually have to be on the x-axis. So as a point, give me an x value that could be. The x value? 7, sure. The y would have to be 0. And if it doesn't matter if it opens up or down? Nope, so give me any a value. In this case, it's opening up, so let's give a positive one. Give me, sure, 9. So let's write the equation. Y equals 9x minus 7 squared plus 0. There you go. Okay. So how would we make no x-intercepts? Sure, above if it's opening up, or below and opening down. So do you want to do opening down this time? Sure, so let's do one below, anywhere below the x-axis. So give me a point below the x-axis. So x is -4, y is -11? Sure. So -4, -11. So which guy had to be negative? Did the x have to be? No, the y had to be. And if he's opening down, give me an a value that would open down. -3 or 17. Okay, so let's make the equation. You could use -1. Yeah. Y equals our a value, -3x plus 4. So that one's always the opposite sign. And then -11. So only the x value is what switches. There you go. Okay, we're almost done. Just a quick review. So what's really important about this lesson? Well, first of all, we have to know that this is standard form. Standard form. Okay, standard form. Also, what's very helpful about this form? Well, they're both y equals. So this one, compared to general form, what's the benefit of standard form over general form? It has the vertex already right in it. You don't have to use your calculator to figure it out. So, what's the vertex here? What would vertex be? H, comma, k. What does that mean? A greater than 0. It means it's positive and it would open up. And the vertex is the maximum or minimum? Minimum if it's opening up. And then the range of the function, range is which one? Dr. XY. Who's that? So y is going to be greater than or equal to, this is h comma k. Which one's the y value? K. So greater than or equal to k. Okay. What does this mean? A is less than 0. What does it mean? It's negative. It's opening down. Therefore, it would have a maximum. So this time it would look like here, and this is h comma k. And this time, what would your range be? Instead of y greater than or equal to k, it would be y is less than or equal to k. And the domain for both would be always x is an element of the reals. And one last thing, the axis of symmetry on the graph is x equals which one? What's the h value in there? H. X equals h. That would give you your axis of symmetry. Okay, so your homework for this is numbers 1, 2 odd, 3 odd, and then 4 to 12. So I just shortened 2 and 3, and that's it for this lesson.